Welcome, everybody, to the last virtual office hours for the POSA Concurrency MOOC in 2015. We will begin in just a moment or two as soon as some people join. All right, I see somebody joining. That's good. Looks like people are coming in. We'll start in just a moment. We'll start up in just a minute as soon as a few more people join. Okay, let's go ahead and start. Welcome to the final virtual office hours for the POSA Concurrency MOOC in 2015. In about 2 weeks or so, we'll be starting the POSA Communications MOOC, and that will cover a lot more topics that are important to build concurrent and networked applications and services in Android, including things like bound and started services, various forms of inter-process communication mechanisms, HTTP, various programming abstractions for HTTP, and other stuff kind of along those lines. But before we get to the next MOOC, we have to finish off this MOOC. So what we're going to be covering today is my solution for programming assignment number 3. Keep in mind, of course, that your solution doesn't have to look anything like mine because it's a very open-ended requirements set, and you're welcome to do pretty much anything you want as long as it meets the requirements. So without further ado, let's go ahead and bring up my solution. Let's see, here we go. Okay, so here's the code. Let's go ahead and make the font a little bit bigger. Let's see, I guess it's okay. 20 points probably about right. Okay, so let's go ahead and start. Make sure this is all centered right. Looks pretty good to me. So what we're going to do now is we're going to walk through my solution to assignment number 3. As you undoubtedly know, there were several different ways to do this assignment. Actually, there's a large number of ways because you just have to follow the requirements. What I did was put out a set of shells that people were welcome to use, but nobody's obliged to use them. And they do quite a number of interesting things. They have some pretty cool material design mechanisms in them. They also provide a nice user interface to be able to specify groups of files to download. And they are designed, of course, in accordance with the model view presenter pattern, like I typically do. So let's just take a quick look at some parts of the shells. We won't walk through everything. just some parts of it so you get a feeling for what they do. So we have the MVP file, which has, as usual, required operations that the view offers to the presenter, and then operations that the presenter offers to the view, and so forth. So here are some of the operations that the view will offer, the required operations that are offered from the view down to the presenter. So we can display the progress bar and dismiss it. We can display the URLs, we can report failures, and we can display the results. Those are some of the things we can do that the presenter needs to have access to. Here's some of the operations that the presenter provides. The presenter has a way of being able to give the URL list back up to the view layer. The view layer can use the presenter layer to start the processing, and it can also be used to delete all the downloaded images. The operations that the presenter layer provides basically are an on processing complete hook, and this gets called back when the processing is all done. And you'll see shortly how that gets used. And that's basically used to interact. Here's the model ops. The model ops are defining the operations that the model layer exports up to the presenter. And in this particular case, it's just the ability to download the image. Once again, there are other ways to do this. I could have moved some of these methods elsewhere. They could have gone, some of the stuff like deleting the downloaded images could arguably have gone into the model layer, but I chose this way just because it made sense to me at the time. Okay, now there's a bunch of files that we have over here for doing the view layer. I'm not going to walk through all these files in detail. There's some pretty cool stuff in here, though. One of the cool things is there's two main activities. There's the download images activity, and this is the main activity that interacts with the presenter layer. And so it has a bunch of things that are used to give a progress bar, the text for adding URLs, ways of displaying the URLs, and so on. And this uses the MVP pattern, so it calls up to the superclass in the generic activity framework to make a presenter instance and connect the view with it. There's also a destroy method that gets called back that's used to destroy the presenter. There's something that's used to start processing, start downloading images. There's ways of adding URLs, deleting images, displaying the progress bar, dismissing the progress bar, reporting failures, and so on and so forth, removing URLs from the list of URLs that are shown on the screen, displaying the URLs when they're all done, being updated, and then the main thing here is something called display results. Display results gets called back by the presenter layer after it's downloaded the files, and as you can see, what it does is it goes to this thing called the display images activity and makes an intent, verifies the intent exists, and then launches the activity to display the results. Although this is outside the scope of the assignment, there's a really cool display images activity here that's intended for being reusable. And internally, it basically uses a cool image loader mechanism that's very efficient to load lots of images in a way that doesn't take up too much memory and is very responsive. There's a factor method to make an intent. As you can see here, it's making an implicit intent where you have to access it via data type and data operation involving a URL or URI. And then there's a whole bunch of stuff in here that interacts with the view portion. And this is actually implemented as a pager, which is a fragment. And you can use that to basically flip through the images that you download and look at them in a more enlarged manner. For some strange reason, there's no easy way to do this out of the box with the gallery application. So we wrote our own little reusable widget to do all this stuff for us. Okay, so I'm not going to talk much more about that other than there's some cool stuff. There's a nice example of a floating action button in here for people who want to learn about material design. And that's basically what's involved with the user interface layer. Much more interesting stuff is taking place over here in the presenter layer. So let's go look there next. So here's some code I gave you. Here's the image presenter, which is a generic presenter. And so that means that it can be basically created by the view layer. And then it will also, when it's created, will create the model layer. And it's all stitched together with weak references, which we use to enable garbage collection. It's got a bunch of state that needs to keep track of where we are with respect to downloading these images. How many are we supposed to download? How many have we downloaded? Keeps track of the directory where all the images are stored. It keeps track of the array list of URLs that have been entered by the user. It has a no-op constructor that's used to be created by the Java operations that work on classes to make new instances. Here's its onCreate method. This is called one time, the very first time the presenter layer is created. This object is created in the presenter layer. It connects the view parameter with the view weak reference. It's stashing away. Creates the timestamp for the image downloads. Goes ahead and makes a directory using that timestamp, so things will get put in a special place. Makes a list of URLs, and then it goes ahead and creates the model layer. On configuration change is called back every time the screen rotates. And so when the device screen rotates, the presenter layer does not get destroyed, only the activity gets destroyed, and the generic activity framework automatically calls back on the on configuration change method, which resets the weak reference and then goes ahead and does some bookkeeping to see where we are as far as downloading the images and display things as needed. There's other methods here that destroy the model, get the list of URLs, reset the fields. Here's an interesting one. This is start processing. So start processing is what's going to get called when you want to go ahead and download some images. Now, this is where I put some comments on what you might do. Here's my solution. As you can see, it's very, very simple. I was going to do something more clever, but I just ran out of time. So this is a pretty straightforward solution that meets the requirements. And what it does is it goes ahead and it iterates through the list of URLs that have been passed by the user. And then for each of these URLs, it will go ahead and make a new download image async task. And we'll look at that in a second. And the download image async task will then go ahead and call the execute of the executor method, this method here. Oops. And execute on the executor will take the thread pool executor that's defined by the async task layer, or the async task component, and the particular URL to download. And we'll take a look at this stuff in just a second. So that's going to go ahead and kick off the processing of that URL that we want to download and then filter. There's also a method that gets called back by the onProcessingComplete method, and onProcessingComplete, we'll see where that gets called back later. What that does is basically check to see whether something succeeded or not. And if it did not succeed, it reports a failure. If it did succeed, it will try to display the images. And the try to display the images method will check to see if all the downloads have completed. And when they have, it dismisses the progress bar, does some bookkeeping information, checks to see whether or not we got any images downloaded successfully. And if so, it displays the results. And then these are just other helper methods that check to see if we're done, and then delete the downloaded images. And here's a cool little delete files method, which is recursive, which will walk through a subdirectory or a folder and delete all the files, and will recursively delete any subfolders that happen to lurk underneath it. Okay, so that's basically the image presenter logic. Here, let's take a look at the code that I wrote to do the image downloading and filtering. At the base of all these two different classes, I wrote a little helper class called image async task. So an image async task is an async task that's parameterized with the appropriate fields, appropriate values, and it's abstract, which means it has to be subclassed by another class to fill in the details. Weak reference back to the presenter. The constructor goes ahead and makes the weak reference to the presenter so we have access to it, and then goes ahead and stashes away the image URL that we want to have downloaded. So that's basically what the constructor of this thing does. Let's take a look at download image task. Download image task is very straightforward. Here's the constructor. It calls up to the superclass, passing in the presenter and passing in a null. because we're not going to get the image to download this particular way. When the doInBackground method gets called back, that'll get called back when the execute method is called. After execute is called, as we saw here, execute is called over here. Actually, we call execute on executor. Let's go find that. Execute on the executor gets called. That will end up calling doInBackground. The doInBackground will grab the URL that was passed in, and then it will go ahead and call over to the model layer and say, hey, model layer, please go ahead and download the image at this context with this URL and put it into this directory. So let's go ahead and take a look at the model layer. Here's the model layer. It's very simple. We have image downloads model, and as you can see, it keeps a weak reference to the presenter, which is set in its onCreate method. OnDestroy method is a no-op, and here is the download image call. So when download image is called, we just pass in the context, pass in the URL, pass in the directory path name, and that then goes and calls over to this download utils method, which lurks over here, called download image, and that then does all the logic that's necessary to figure out how to actually download the image and store it. And the meat of this thing is in a method called create directory and save file, where it will go ahead and that's actually in a different location. That's in another utility. I think that's over here. So this thing will go ahead and create a directory and save a file if one exists. And what it does, this is actually where the call is made to download the file, the image file, and that gets stored in an input stream, and then we go ahead and copy the input to a local file, and then we send back the path name of that local file. This was all code that was given to you, so you didn't have to write this code unless you wanted to. You're certainly welcome to write it if you want, but I provided this code because we really weren't focusing in this example on the networking operations. We'll cover those in the next course. As it turns out here, we don't really need to have this presenter. We could have omitted that and nothing would have been amiss, but in more general applications, you might need that. That's basically how doInBackground works. We download the file in the background, and that gets stored into a file as a result of downloading. When we're all done, download image returns the URI to the file that was stored from the download. That URI comes back as a URI from doInBackground. That method will then get called, that path will then get passed to onPostExecute. If you recall, onPostExecute is the method that executes in the user interface thread. And what it does, what it's called back, in this particular case, is it takes the path to the image file and it makes a new filter image async task after first logging some information. And then it goes ahead and it goes ahead and creates the image async task, passing in the presenter's reference and the image URL that we want to download, or that we have downloaded. And it calls execute on executor, passing in the thread pool executor once again, so that'll run in the same thread pool, and then passing in the path to the image file that we want to have modified. So what that'll do is it'll go ahead and create a second async task. And let's go over here and take a look at that. Here is filter image async task. Filter image async task is an image async task. Its constructor squirrels away the necessary parameters. And its doInBackground method does something a little different. What it does, it's given the URI to the unfiltered image that was downloaded. So it takes that unfiltered image, and then it goes ahead and it calls out to the grayscale filter method that's in the bitmap utils, which you're welcome to use or not. You don't have to use that. And that goes ahead then and will apply grayscale filtering to the file that was downloaded, and it creates a new file, and it stores the filtered image into that new file. And because I didn't want the unfiltered image, I then went ahead and simply deleted the unfiltered image. So I got rid of the unfiltered image. You could also keep that around if you wanted to, not a problem. That wasn't strictly part of the requirements, but you're welcome to do whatever you'd like to do. So if you don't delete that image, then you'll have both a filtered and an unfiltered image. If you do delete the image, then you'll just have the filtered image. But it's totally up to you what you want to do as far as that goes. When we're all done, we return the filtered bitmap URI back to the result of doing background. That triggers a call to on post execute, which of course runs in the user interface thread. And because we're running in the user interface thread, then we're able to call back to the presenter, and we say, hey, presenter, we're done with our processing. Thank you very much. And that processing then will take the URL that we downloaded originally and the filtered URI that we have modified with our grayscale filter, and it calls back to the presenter layer, and that will call back the onProcessingComplete method. And as we saw before, onProcessingComplete will then go ahead and either report a failure if we couldn't download the image for some reason, or we'll go ahead and try to display the image. And obviously, there's all kinds of different ways to do this. This is my way of doing it. Won't even say it's the best way of doing it, but it works well. And the end result is nice and clean and efficient. Okay, so that's basically, in a nutshell, how this program works. And just a couple things to note. You'll see that when we make the original call with the execute on executor, we're passing in the thread pool executor. That was requested in the specification for the program. Obviously, you could have created your own thread pool had you wanted to. There's nothing necessarily wrong about that. In fact, it's good practice to get in the hang of knowing how to do it. It just didn't seem like we necessarily needed to do it in this example. The thread pool executor that's part of async task tries to be smart about how many threads to allocate for the thread pool based on how things work with respect to the number of cores that are available on the machine. Okay, so that's basically the code. Let's pop back over here, and what I'd like to do now is, if there's any questions, I'll be happy to go ahead and talk about them. There's a couple of things I want to go over. Someone had asked a good question yesterday on the discussion forum having to do with the strange comment in the async task documentation that says async tasks should not be used for long duration operations. So just for kicks, let's go ahead and take a look at that. Bring up the browser here for a second, and we'll share it. So let us share this piece of wisdom from the Android developers. So if you take a look here, it says, async tasks should ideally be used for short operations, a few seconds at most. If you need to keep threads running for a longer period of time, it's highly recommended that you use the various APIs provided by the Java Util Concurrent package, such as Executor, Thread Pool Executor, and Future Task. Now, of course, what's so funny about this, I believe this comment is misleading at best. And what they really should have said was, if you use async task and you just call the execute method, then this comment applies. And of course, the reason for that, as we talked about when we went through the source code for async task, was that by default, the execute method will simply run each async task serially within a process. So it runs it in a background thread, but there's only ever one of these async task computations that'll actually be running at any given time if you just call execute. So in that case, it does make sense. You don't want to have things running for a really long time with async tasks, because if it runs for a very long time, any of the other async tasks that are using the default execute method will end up blocking for an extended period of time, which is not good, because they have to wait their turn. The solution to this, though, is absolutely trivial. All you have to do, as we did in assignment number 3, and probably also assignment number 2, and now that I think about it, is use execute on executor and pass in a thread pool executor, either the one that comes by default or the one that you create, and then in that particular case, the computations can run concurrently. So all of a sudden, what you're doing, really, if you look at the code, and certainly if you write your own thread pool executor and connect it via the execute on the executor, you're following the recommendations that are exactly what's being said in the documentation. You're using the Java Util Concurrent Executor framework and the thread pool executor. So I've always thought that that comment was misguided at best and misleading or even wrong at worst. So as long as you are using the right versions of the async task methods, then you shouldn't have any problems. Okay, so let's take a look at some of the questions. We've got lots of questions. That's good. First question, can you please give us some guidelines for grading? So go ahead and take a look. There's the rubric is what you'll be filling in and fleshing out for the program, and it asks you basically, I think it's 4 different kinds of things or 5 different kinds of things. Does the code, did the person upload the code correctly? That sometimes doesn't happen. So if they don't give you any useful code, there's obviously not a whole lot you can do there. You have to give them very low score. Then the next question is, does the code compile? And the idea, of course, is that everybody should be using the same version of the API version 22, which is what I used. So as long as you all follow that rule, that hopefully the code will compile. If it doesn't compile, they don't get points. If it does compile, they get points. And then it says, does the code run correctly? And for that, of course, you need to actually try executing the code either in an emulator or on an actual device. I would recommend using an emulator just because you never know where the code might be doing bad things, and an emulator is going to give you extra protection from malicious or accidental mistakes. So if you run the emulator, then you should see, does it actually work? Try giving it some files to see if it downloads them properly. And as part of that process, also make sure that you do a little stress testing. So try rotating the screen and see what happens when you rotate the screen. If things are done properly, then when the screen rotates, the computation should still continue and the program shouldn't crash or the result should not be incorrect. So that's another thing to evaluate. And then the last thing, I think, basically just says, did they fulfill all the requirements that are specified in the program specification? So that means, do they use async tasks correctly? Are they using async task thread pool executor? Is there a separate async task for each of the different download and filter operations, and so on and so forth? So that's pretty cut and dried. If somebody has done all those things, they get full credit. If they did none of them, they get no credit. And I think there might be partial credit for that one if they did some of the things, but not all. So, so those are basically the ideas of how to do the evaluation. Let's see. Somebody said they joined late, but I didn't extend generic async task to do what I did. Yeah, I didn't. Generic async task is really intended to be used for a slightly different purpose. And so if you watch the next MOOC, the POSA Communications MOOC, will use generic async task. In fact, if you poke around in the source code for various examples in the POSA 15 and mobile cloud directories, you'll find lots of examples of using generic async task. It just wasn't really necessary for this particular example. Let's see. I noticed another question. I noticed an interrupt method in thread class calls another method interrupt, which is a native method. What does this method do, and where can I find its source code? So you'd have to be much more specific to help you out there, like which version of Android are you using, and specifically where are you finding this code. But my guess is that under the hood, that's probably native code that's part of the Java Util concurrent package. It's probably part of the thread implementation. If you have the Android source code, then you would go and look in the .cpp files, because I have a feeling that that implementation is probably written in C++. If you watch some of the videos, I actually kind of walk through the different files. If you watch the early video from week number 1 in the class where I talk about threading, you'll see a discussion about the different layers and classes and methods that are called. And so if you take a look, there's a implementation in C++, and that's where that code is going to reside. And my guess is that what the interrupt call is probably going to do is it's probably going to send a low-level interrupt request message. That's what it's called in Java thread nomenclature. It'll send an interrupt request message from the calling thread to the thread that's running, and that will then be used to indicate whether or not there's a request message, and different parts of Java, either native code or Java source code for the thread package, will check to see if that interrupt request has been sent, and if so, certain things will happen, right? So in the case of blocking calls, then those will wake up and throw the interrupted exception. In the case of non-blocking calls, you have to be obliged to check periodically to see if the thread has been interrupted. And there's a couple of different ways to do that, which are talked about in the lectures. So, so you can find that code in, most likely you'll find that method in the C++ code. Should the app cancel the scheduled and running download and filter tasks upon exit? That wasn't part of the requirements, but you're certainly welcome to do that. I have other versions of this assignment that we'll use later in probably in the next MOOC that's coming up, that actually involve having a cancel button that you can use to cancel the downloads. And when downloads are canceled, then various things take place. And there's a lot more bookkeeping information that's required if you want to cancel stuff correctly, and it's a bit more complicated, but we'll probably cover that in the next MOOC. Let's see, next question. Can you go over the places in your solution where you create and use weak references? Sure, I'd be happy to. Let's go ahead and open this up. Obviously, I will show you some of them. I don't know if I'll show you all of them, but they're very simple to find. Just look for new weak reference and you'll find them. You'll typically find weak references being created whenever the different types of MVP references are passed from one layer to the next. So if we go up here, for example, we will find a situation for download images activity where we say on create, and we pass in this. This is a hard reference, not a weak reference, a strong reference to the download images activity. So that's being passed to the onCreate method. Now the onCreate method, as you may know if you've watched the video, is part of generic activity. And so onCreate over here will get pass this thing in as a required view ops, and then that will end up calling initialize with that strong reference. And initialize will come over here. It'll make a new presenter based on whatever type you passed in. Let's say it's the image presenter. And it'll store this into the retained fragment manager. And then it will go ahead and call the onCreate method of the presenter instance. So that's, and notice it passes in the strong reference to the view. So the onCreate method is called there. Go over here and we look for onCreate. We'll see that this thing gets passed in as a required view ops. So that's the subset of methods that are exposed from the view layer and the view layer's activity into the presenter layer. And now we've got to be able to make a weak reference to the view layer, because we do not want to keep a strong reference to the view layer, because if we keep a strong reference to the view layer, then whenever the phone is rotated, the activity will be destroyed, and we will end up holding a strong reference from the presenter layer, which means that that object will not get garbage collected, which is a bad thing. So rather than holding a strong reference, we hold a weak reference, and then we have that weak reference stored here in this thing called mview. So if you just search for weak reference, you'll see that mview is a weak reference. And that means that it's not counted as a true reference. So the reference count is actually not incremented for the activity object. It does not actually have a strong reference. It only has a weak reference. So when the activity goes away, it can be cleaned up and properly garbage collected by Android and the Java runtime in Android. So that's one place where it gets used. You'll also see we do something similar inside of the download image async task which it gets from the image async task over here. There's a weak reference that's stored there. Same idea. We do not want to have a strong reference here. We want to have a weak reference so that if things go away, we don't have problems with reference counts, preventing garbage collection from taking place. So that's another place where this occurs. And then if you go over and look at the model layer, remember the model layer is called here in the presenter. When we have the presenter get created, it goes ahead and creates the model layer, and it passes in the presenter reference. So if you go look at the model layer, then you can see that the onCreate method here goes ahead and makes a weak reference to the presenter. So the model has a reference to the presenter has a reference to the model layer has a weak reference to the presenter layer has a weak reference to the view, and those weak references are used in order to ensure that we can have garbage collection take place properly. So that's basically how that works. All right. So let's see, here's another question. Let's go back here and stop sharing for a second. Is there any reason other than the requirements not to combine the download and filter process into a single async task? Sure. If filtering were to take a long time to run and you had other cores on the machine, let's say you had a lot of cores on the machine and you were downloading lots of images, then of course you would want the downloading and the filtering to run as concurrently or in parallel or simultaneously as possible. So that's the motivation for that. If you do them in the same async task, then you have serialized those operations. And if you so if you had lots of images to download and lots of long-running filters to run, and you had lots of cores, you would not be taking full advantage of the parallelism available on the machine. So that's the thinking there. That's why we did it that way. Obviously, in practice, all this stuff depends on a whole bunch of factors. How many cores do you have in your machine? How long will the operations take to run? And so on and so forth. How many things are you going to be trying to do simultaneously? So your mileage will vary. And in practice, you would probably want to do some experiments to see what worked well and what didn't. But I just wanted people to get some practice with it. And there are good technical reasons for wanting to do it. So you're getting practice with something that may actually pay off. Another question, is there a video or source for a better understanding of thread pool executor? Why, yes, there is. So there's a couple of places you can go to find information on thread pool executor. Let's see. So one place to go, one place to go find information on thread pool executor. Let me bring up a browser and I will show you a couple of different places to go. Let's go over here, bring up a browser, and let's make that guy be the foreground. So first thing, let's go ahead and go to the class. Oops, nope, it wants me to log in. Well, let's log in. There we go. That's a little bit more useful. So if you go to the video lectures, and you poke around in the video lectures, I think it is week number 2, or maybe week number 3. Here we go. Week number 3, the Async Task Framework Implementation Walkthrough walks through how Thread Pool Executor works. So you can see how Thread Pool Executor is used if you take a look at the Async Task Framework Implementation Walkthrough. And of course, the reason for that is that the async task implementation itself uses a thread pool executor. So that's one place to go to find it. But of course, there are other places to go as well. So another place to go is to go out to my YouTube channel. And you can go and look at the, there are a couple different ones here. This is the 2014 YouTube channel. This is CS282 2014. And if you poke around in here and you go down somewhere, we have the Java Executor Framework. So Java Executor Framework Part 1, Java Executor Framework Part 2. And those are both videos that go into a great amount of detail on the Java Executor Framework. And of course, part of the Java executor framework is the thread pool executor. So that'll go into a bit more detail. And yet there's yet another place to go to look here. So let's go over here to MOOCs and digital learning. And I have a live lesson called Java Concurrency. And this is, oops, don't want to watch myself. So basically, these are some instructional videos I made for Pearson that goes through lots and lots of stuff on Java. If you're a Safari book club member, then you can watch these videos, and they go into a lot of detail on all kinds of aspects of Java. And there's a whole discussion here, 3 videos about I guess an hour long or so, talking about the Java executor framework, and that goes into lots of detail also on thread pool executors. So those are some good places to go to find out more information about thread pool executors. Let's see. Okay, so there's a question. Was the use and extend of async task required for the correct configuration change handling? So I'm not quite sure I understand what you're talking about. Let's see if we go back over here, and I'll bring up the code and I'll explain it. And if I don't explain what you're driving at, let me know, and I'll be happy to go and re-explain it. Let's peek down at that code again. So you'll remember that download image async task extends async task, and filter image async task extends async task. And then async task is the class that actually extends, I'm sorry, image async task is actually the class that extends async task. And the reason I did that was simply to factor out common code. I saw no reason to keep the to duplicate the code. So there were a couple things I always needed to have access to. I needed to have access to the presenter, and I sometimes need to have access to the image URL for error reporting and diagnostics and so on. So I just created a new class called image async task, and I stuck all that information into image async task. And then I inherited it, so I didn't have to repeat myself. So that's basically just the don't repeat yourself pattern that you might hear about if you read about how to write code that doesn't require as much effort when you make changes. So dry or don't repeat yourself. That's a good example of the dry pattern. Let's see. Is it less effective if somebody passes to the download filter image async task constructor only the URL from the MURL list rather than the whole presenter instance? I suspect it would be no difference whatsoever. I passed the whole thing down there because I wanted to be able to get back to other methods that were part of the presenter interface. Like I wanted to be able to go and get access to the model, and that's part of the presenter. So I did that on purpose so that we would have the right level of visibility into the methods that the async tasks needed in order to do their job and to collaborate with the presenter layer, like to call on processing complete, for example, when things are done. So I don't think that there is actually one iota bit of difference. Those are just references. They're just little pointers. And so it shouldn't make any difference at all, really, because everything is already passed by reference or passed by pointer in Java for the most part for non-primitive types. So there's really no win that you would get from restricting those things. The only reason you would restrict that information is if you wanted to have a narrower interface or narrower coupling between the presenter layer and the various async tasks. But I didn't want that. I wanted to be able to get access to the appropriate portions. And you can also control that too by restricting what's actually passed in various ways. Is there any difference between passing data to async task via its class constructor and its do and background parameters? No, not really. It's all up to you. Basically, when you call execute, you have to pass in a particular data type, which is the type that you specified as, I believe, the first parameter to the async task generic abstract class. And execute can take an array of those things. You typically don't pass an array, you just pass one, but you could pass multiple things. But if you pass multiple things, they all have to be of the same type. And so using the constructor, as I did here, is just a nice, clever way of being able to get more data passed than you can easily pass to execute. But there's really no particular difference. I suspect you could profile and measure the performance of your solution from here to eternity, and it would make no difference whatsoever in the performance, because it's just not part of what matters in terms of overhead. Okay, well, looks like we're kind of rounding out the hour here for virtual office hours. I'm certainly happy to take more questions if you have them. I will also just give you a little preview of what we're going to cover in the next MOOC. So if you were to go and take a look at the next MOOC, let's go ahead and do that. We have a couple minutes left, so let's go over here and see if we can share the screen again. Let's see. Okay, share the browser. So let's go over here to Coursera.org course POSA communication. I think that's the right thing. There we go. Okay, so this is the POSA communication course. This is the one that's coming up next. Here's a preview of the syllabus. This, of course, might change a little bit between now and when we actually start, but I suspect it'll probably be more or less the same. What we're going to cover in this class will be an overview of Android services, started services and bound services, and then all kinds of various local inter-process communication mechanisms that are used to communicate from activities to services. And so we'll talk about messengers, we'll talk about intents, we'll talk about the intent service, we'll talk about programming bound services with messengers, we'll talk about programming unbound or started services with messengers. We'll talk about using the Android interface definition language, and then we'll also talk about programming and communicating between activities and bound services using AIDL. We'll also spend some time talking about inter-process communication mechanisms you get with Android, so you'll learn about how to communicate using various communication abstractions for HTTP programming, such as the Android clients and other kinds of things. And then at the end, we'll talk about some patterns like we did last time, and we'll talk about various communication patterns. So those will be the main topics we'll cover. A couple things to note: this class is going to be running over the holidays for many people. Not everybody, but many people have holidays. We're going to start after Thanksgiving, which is a US holiday, of course. And then naturally by the middle of December, a lot of people tend to go on vacation for a whole bunch of different reasons, for different holiday seasons and so on. So we actually have 4 or 5 weeks of material, but we're going to stretch the course out longer so that people can take a break during the holiday and they don't get behind. So naturally, you're welcome to watch the videos and do other things, but this is about 4 weeks or 5 weeks worth of material stretched into an 8-week period of time. And then the whole reason for that is just to not drive people completely insane by forcing them to work over the holidays, which would be annoying to many people, probably myself included. And so we want you to take time off if you choose to and have a good time. The course that'll come after this one is a little mysterious at this point, but it's going to be something called POSA Content, and it will focus on content providers and SQLite and things like that. We'll also get a chance to play around with some things like retrofit and so on. Okay, so people ask, is it okay to discuss the code on the forum? You're certainly welcome to discuss the code on the forum. Please don't post your code on the forum. Discussing is fine though, because we don't want to violate the honor code and so on. Why do we use a weak reference in the model layer? The model layer doesn't get destroyed due to screen rotation. Just a good habit to get into, really. It doesn't have to be that way, but we don't want to have hard references. Creating hard references between layers is just asking for trouble. And so making things be weak references keeps it more decoupled, it keeps it more consistent. You don't have to stop and ask yourself the question, why is this a hard reference here versus not a hard reference there? And in general, it just means that the garbage collector has better opportunities and you don't fool yourself into creating memory leaks unexpectedly, especially in programs with high degrees of concurrency. Okay, well, thank you all very much. I really enjoyed interacting with you, and we will, of course, hopefully be back in touch in a very short period of time, basically in about 2 weeks when the next MOOC starts at the end of November. So thanks again, and I will look forward to talking to you later.